Then I'll be overwriting the recording of my other class. I'm pretty sure they won't be very appreciative of that. All right, so what we'll do today is we're going to look at the current homework assignment, the one that was due today, and I'll just kind of show you guys quickly, how to write a program. Are there any questions about that particular app? Did anyone encounter any significant problems with that? Not really? Okay. So I'll just go ahead and give you the solution to that one, just in case someone could not finish this homework assignment. Not this one, not the one that you're looking at. That's from a different class. From the class right before this one. Although I can see, some relationship between these two classes, we can do something related to the other class.
Is it going to be the lottery one?
No, it can be find the shortest path.
Yeah.
So you can solve the problem with your current homework assignment and compare your solution to the optimal solution. We're not going to do it this time. All right.
Why not? We're going to know.
Sorry?
Nothing.
Okay, so the homework assignment that was due today was get them all. Okay. And the first thing, obviously, is to make sure that we read the description correctly and understand everything that we're supposed to do. The design part is easy. One canvas, one multi-purpose button, and a label. And then inside the canvas, we have one single sprite that has to start from the center of the entire canvas. The button is the problem, because the button is a multi-purpose button, which basically means that you have to change the caption on the button and also change what it should do depending on the context. So now you have to look at all the different things that we can do with this particular program, and then we say, okay, of all of these things, what can we do with that button? Upon initialization, the app should remain static and do not start the game automatically. The text of the multi-purpose button should read start. The label should display let's start the game. Upon clicking of the multi-purpose button, if no game is in progress, which means a game in progress is a state, no game in progress is another state. If no game is in progress, start a new game. We'll describe what the game is supposed to do later on. But once the game starts, you want to change the text of the button to say pause. If a game is in progress, it is being played right now, and the empty button is pushed, then you want to resume the game if it is already paused, and update the multi-purpose button to pause. If the game is not paused, then the button would basically say pause. Then when you click the button, you should pause the game and then update the text of the multi-purpose button to resume. If the game has concluded, clicking the button should reinitialize a new game. Upon long clicking the multi-purpose button, it's only meaningful, the long clicking is only meaningful when the game has already concluded. Then you can reuse the same 7 positions as the game that has just been concluded and then start the game again, but reuse the positions from the previous game. And the game is played like this. Upon initialization, we clear the background. We specify a particular background color. Draw 7 circles at different coordinates in a non-overlapping way. So the first thing you need to do is to detect whether something is going to overlap or not. If it is going to overlap, don't draw that. You just pick another coordinate. You want to fill the circles, and the fill color must be a color that is different from the background, because otherwise you cannot see it. At the center of the canvas, you want to place a small bright ball sprite, and you can choose the color of the ball sprite. And then you need a timing mechanism, which is basically saying you need a clock. The gameplay is when the game is in progress and not paused, the label should display the number of seconds since the beginning of the game, and the label should be updated every second. Okay, now that's telling you that you need to use a clock, and the timer has a period of 1 second, which is 1,000 milliseconds. Okay, very good. When the game is in progress and paused, the number of seconds since start of the game should also pause. It should still display, but it should not count any further. When the center of a ball is over a painted filled circle, remove only that circle from the canvas. But in order to do that, you need to know where the center is. Just knowing that you're over a particular painted circle is not enough. You need to find out which circle it is so that you can paint it over with the background color to make it go away. The game concludes when all filled circles are removed in the game. And when the game concludes, update the multi-purpose button to new game in parentheses long press retry. Okay, so are there any questions about how the game is supposed to play or the app overall, just overall speaking? No questions about that? Okay. How did you guys get started with this particular program? What was the first thing that you do? Create the interface and then
Make balls.
okay, paint the balls, right? You'll paint the 7 balls.
Start game.
Now, that works well with a homework assignment like this. I would call this one a fairly simple and easy homework assignment. Okay, it does not represent the complexity of an actual app. Okay, your project is most likely quite a bit more complex than this. Okay, and I think in the previous class I also started to talk about the state diagram thing. Do you guys remember the state diagram? So the state diagram can be useful in this case because you can identify the various states of this thing, and then you can draw the connections like, okay, how do we transition from one state to another state? Okay, so I will do the same thing in this class, and since we can use the that might be a little bit problem here because if I disconnect, because I can use my document viewer, because this is one case where that can be handy. I have to disconnect the microphone first, so then I have to re-establish the connection. So let me see if
Structure of the software.
they design the overall, the overall structure of the software. Okay, not quite the logic, but the structure of the software. And why do you think that UML is important to software architects?
Well, it's kind of a way of mapping how pieces fit together, how objects fit together.
But as a document or as a diagram, it is meant for communication or it's meant for documentation, right? So as a documentation, you can say, oh, maybe the software architect just needs to remember how things are supposed to be, and this is more or less note to self. But that's not the case, because if it's just note to self, then you don't have to conform to a particular standard, because you just have to do things however you can interpret and parse later on. So why do you think it is in the UML, or the unified modeling? What is the L? Language, right? What do we need language for?
Communication.
For communication, okay? So who's going to read these diagrams and pictures and whatnot? Exactly. Software engineers and programmers will also need to look at these diagrams to understand, oh, okay, so the overall architecture is like this. I'm in charge of this piece. It is supposed to interface with that piece using this method, and so on and so forth. So that's why the UML is actually important, not only to software architects, but also to software engineers as well as developers. developers and software engineers are not exactly the same thing. They kind of overlap by pretty good portion, but they're not exactly the same thing. Do you guys know the difference between a dev or developer as opposed to a software engineer?
I think software engineer has slightly more, slightly larger job scope than a developer.
Okay, yep. Okay, so since I'm going to talk about the UML, I do want to kind of mention, the differences between the developer and the software engineer. The best place to go look for this type of information is already paid for using your taxes or your parents' taxes. Okay, because it's a particular bureau of the government. So it's the Bureau, I know I misspelled it. Okay, the Bureau of Labor Statistics. Okay, quite far off too. Bureau. Okay, fine. Okay, when you go to the Bureau of Labor Statistics, you can look up, all kinds of tools. Okay, one of the tools you can do is to look up job outlook for certain types of jobs. So you can go to, let's see here. Or you can just look for Outlook, Occupational Outlook Handbook. And under the Occupational Outlook Handbook, which is updated fairly frequently, which is nice, you can then look up Computer and Information Technology, which is down here. And under here, it has a quick table of all the various occupations related to computer and information technology. And then you can look up, just on this table, you can look up a job summary, entry-level education, as well as what most people care about, the median pay. And you can sort by median pay too, which is already sorted by in decreasing order, which is probably because most people want to sort it by decreasing order. So you can look up programmer, which is a way to refer to developers, as well as software engineers. So computer network architects, it's not sorted in by pay, but software developer is here. They classify slightly different as programmers, but they should have software engineers. Okay, that's programs and engineers. I don't see engineering in here. Okay, so they haven't really updated to use the terminology of a software engineer. But when you sort by pay, you can see that the research scientists have the highest pay. But now the question is, how many scientists do we need? Well, technically speaking, we do need more because of software security. But the actual in the actual world, they don't need a whole lot of scientists. They need a lot of developers. Now we know that the computer science need a lot of developers. Why? Steve Ballmer. Oh, you guys haven't seen the video with Steve Ballmer, screaming developer like 20 gazillion times, and he was sweating the whole time. No, you haven't seen it. Okay. But I'm guessing they are including software engineers in software developers in this case, because the pay scale of a developer as opposed to the pay scale of a programmer, there's a pretty good discrepancy between those two. You can see programmers are down here. The median pay is about $80,000 per year. And then with software developers, which I'm guessing they're including software engineers into this group, is $100,000 per year. Yep.
Yeah, I read an article that there was an article saying that companies should go to software engineering, but basically there's two tracks. Like a company picks software developer and software engineer, but I think that the article was trying to sway towards going to the engineer because it had a more logical. But basically, companies kind of pick one of those tracks and go from one to whatever.
Right. Well, you can cross tracks. I mean, these tracks can be crossed, fairly easily, especially when you have the know-how. You can usually cross the tracks.
That much difference in the jobs. I think it was just the terminology that companies were using.
Right.
They either picked software engineering as a terminology, you start with engineer one or whatever,
yep,
versus like
developer?
Yeah, developer, associate developer, I think was like the first step in developer.
Okay.
Land, and they kind of matched the ranks.
Oh, it's just a term.
It's just
you know,
a term that a given
Yeah.
organization chooses.
Yeah, but in real world, you can actually see similar type of differentiation. But when you build a house, okay, when you build a house, you have the architects, right? What do architects do when you build an actual house? When you build an actual building, the architect is the one who designed the overall thing, okay? And what do you think the architect has to take into consideration? Because this is one way to define a job is what is the input, what is the output, right? So what is the input to an architect? Sorry? Go ahead. Measurements? Maybe measurements of the site, okay? Where the building is supposed to be, okay? They also need to take into consideration of the client, right? So the client can say, okay, I want a building that looks normal, right? Or I want a building that looks really, really interesting. I want a building that is super energy efficient, or I want a building that is just average. Make it cheap, right? Okay, so those are the input coming from a client. So the architect has to look at all of these considerations and come up with a design. So the architect comes up with a design, and usually how would an architect let people know of the design? Is it like some kind of random drawing in ketchup on a piece of napkin? No, it's
they draw.
They draw, and there's a particular name for that really kind of long sheet of paper. It's called a blueprint. Okay, very good. Well, traditionally it's a blueprint. These days it's all CAD-based, so it's a little bit different these days, but it's called a blueprint.
They still call it a blueprint.
They still call it the blueprint. Okay, so what do you do next with that blueprint, which is a specification of the building? It has all the dimensions. It tells you, where the columns are, how tall each floor is, how to partition the rooms, where the faucets are, where the switches are, and so on and so forth. So what do you do with that blueprint?
Give it to a contractor.
Construction market.
That's one step in between.
Approve it?
Huh?
Approve it?
You have to get it approved, and what are the factors to get something approved? And what people are going to approve it?
The client.
Not the client. The client has to say yes to it. Yes, I like the look of this building. I think it meets all my requirements. But in order to approve the actual groundbreaking and the building of a structure, you need approval from civil engineers. And what are those people? What is the input of those people? What is the output of those people?
Physical laws.
Physical laws, exactly. Okay, so they have to look at the actual structure, okay, and say, okay, this looks interesting. Okay, so let's say you're trying to build a house. This is a cliff, right? And you say, I really like my a house to be built over here, and I want the bottom floor to have a glass floor, so that each day I get to the bottom floor, the bottom floor of this house, I can look down and enjoy the view of, I don't know, if this is like, if there's waves crashing into the cliff, you can just watch and go like, wow, that is cool, okay? Or if this is the Grand Canyon, okay, you can look down and go like, oh, that is really cool. Okay, so the architect can do this. Okay, the architect can say, oh yeah, we can do something like this with some kind of transparent support supporting the house over the edge of a cliff. And then the engineer will come in and do what? The engineer may or may not say no, okay, but the engineer is the one who will figure out all the technical details. So the engineer will actually go on site, test the soil or the rock type, okay, to see whether it is solid enough or not, okay? Because you don't want to build this thing on something that is going to be shaky or it's going to erode away really soon, right? So the engineer will actually test the type of rock, the type of soil, and so on and so forth. The engineer will also specify what kind of material is applicable here. Okay, is it fiberglass? Is it how thick of glass, or is it some kind of polymer that has that is transparent and so on and so forth. So the engineer actually find out what type of material, do all the calculations, and then say, okay, if you want this to support this, we will also need if you don't want anything to kind of obstruct the view down, okay? So the engineer may say, well, yes, we can do this, but you will need something like this, and you need a cable to suspend the entire platform so that it doesn't fall over. And then the other part here has to attach to another point over here so that there's no torque to try to pull it over this. It's really just this is all sunk into the ground to make it solid. So the engineer is the one who has to come up with all of these things to make it feasible, to actually make it buildable. Is that making any sense? So once the engineer is done, and the architect said, well, I guess I didn't factor in this, but the client says it's okay to have the suspension cable and whatnot, okay? And then what happens? You have the blueprint incorporating all of this stuff from the engineers. Whatever branch of the government is in charge of this particular area says, yes, it's okay, it looks kind of weird, but it's okay. Okay, and then what do you do next?
Construction group comes in?
You need a construction group coming in, and we know those people usually as contractors. It's just overall speaking, they're called contractors, right? Okay, so we now have these people, right? We have architects, we have the engineer. Now each one is just a group of people, not a particular person. Architect. We have engineers, and then we have contractors. All right. So with these terms, how do we correspond these terms to computer information science? We have software architect, we have software engineers, and then we have programmers. So contractors are basically the programmers. What we call software engineers or developers are the engineers. And then we also have software architects, and they are the ones who are overseeing the entire project from the perspective of, they're the highest level. They see the highest level perspective of the entire project. Okay? But why am I even talking about this? Remember the original thing that we were talking about was the UML, the Unified Modeling Language. So what ties all of these people together? What is the one thing that all of these people need to understand? The blueprint. Okay, so in this case, it is the blueprint. Okay, so the architect passes the blueprint on to the engineer will figure out the forces and whatnot. And then the engineer, once everything is approved, the blueprint gets passed on to the contractors. So the contractors will know, okay, so we need to sink this column down to a certain depth. We need to wire the electrical wiring this way. These are the switches, those are the lights, recessed lighting. This is where the fireplace is. That's the chimney, and so on and so forth. But they will actually be following the blueprint in order to make it reality. Does that make any sense? So in the software world, instead of a blueprint, we have documents in the UML. And that's why the UML is actually very important, because it's not just the architect or the engineer who needs to use that. It's also all the way down to the contractors, or in this case, the programmers. Okay? All right. So now that we established that the UML is useful, we can now look up UML and what we call activity diagrams or state diagrams. Yep.
In the agile modeling, you have like Scrum Masters. What is that role compared to?
I'm not familiar with that term.
Project management. That's yeah. Agile is a method for doing project management, and it's a good methodology for not doing anything else. That's what it's for.
It's more of a mindset also, than anything else. You're not waiting for everything to be fully specified before you do something.
Yeah, I mean, the Scrum method itself is a project management method. Agile development is more of the collection of interrelated methods based on the same concept.
Okay.
For software development.
Yeah. Well, you could theoretically use it for other things, but software is where it originated.
Okay, but getting back to this particular project, so now that I get my document camera up and running, oops. That's not the one I want. I want VLC. So now we can draw a diagram. So what I'm doing here is to do the homework assignment, but instead of just jumping in to do the coding, I want to explain, in real world, in a bigger project, how do you document the behavior of a program that is interactive. So it'll be helpful if this thing can project like a laser line, so I can just line it up to the laser. Okay, there we go. Okay, so we now have several states, okay? And in the UML, you don't have to, I'm not going to test you on this, okay? So oh, you cannot see that though. There we go. So this basically is a solid circle. It represents the start of everything, okay? So when you start an app, it goes into a particular state. Now this is not, entirely, strictly, following the UML documentation standard, but we have the initialization screen. Okay, so this is the initial screen, or the initial state. And from the initial state, we have several ways to. We only have one way to proceed, which is to start a game. Okay, so when we start a game, we end up in another state. And I'll label the arrow later on. When we're in this state, which is in game, okay, so the game is progressing, and let me just look up the text to see how I describe it. In progress. Okay, so we have a game that is in progress. Okay, in progress. When the game is in progress, you can have one transition to another state. What other state can we get into? The game is already in progress, we can pause it, okay? So we can say paused, that's the other state. So it can go between these two states, right? But it also has another state that can end up with, which is
finished.
Finished, yep. So it can also go to another state, which is finished. Finished. And from finished, we have two ways to proceed back to the beginning of a game. So we have two ways to go back to in progress when the game is finished. So we have two transitions here. 1, 2. Okay. So now we have represented the various states of this particular app. And we have also stated what state can transition to which other state, because it's not interconnected. There are certain states that are not connected at all. Like, for instance, you cannot go from paused all the way to finished. That doesn't happen, okay? Now we have to label these arrows. How do we go from the initial state to in progress? You click something, okay? It has to be some kind of event that triggers the transition of the whole app from one state to another state. So in here, we click the start button. In here, we click the pause button. In here, we click the resume button, right? And then this transition is a little bit tricky because it is getting the last filled circle erased, okay? So we just say last circle erased. That will get us into the finished state. And then from the finished state, we can go back to the in progress state using two different ways. You can either just do a single click, or you can do a long click. The single click is going to randomize the 7 balls to restart a new game that is completely different from the previous one. The long click will use the same 7 balls as the previous game to restart the whole game. Is that okay? Any questions about this particular state diagram? Yep.
Long click and then the smaller row is what?
The smaller.
Long click will start the game again, and the smaller row near it.
Okay, that's just a click.
Just a click.
Yeah. So this is a long click. This is a single click.
So just the click can start again.
Yeah. That's how the description of the homework said. A regular click will restart the game, but with different positions or new random positions. There's a very off chance that they can still end up in the same 7 positions, but the chances is really low. Okay. So all the work, okay, is really done in the transitions in a state diagram. When you're in a particular state, it really doesn't do much. Okay. So obviously, in this case, we are making this a lot more simplified than this really should be, because when you look at in progress, okay, it becomes its own little state diagram. Because when you're in progress, you will basically have various states, which in this case is whether your sprite is on top of a filled circle or not. Okay, if it is, it's one state. If it's not, it's another state. And the transition between these two states will be triggered by the drag event. So when you move the sprite, when you drag, then you can potentially end up in a new state, or you can remain in the same state. So, but I'm not going to view the nested state diagram, but I'm just going to say that in one single state it can explode into its own state diagram, so that you can express more details as to what your program is going to do, when it's going to do it, and what triggers the state changes. Are we doing okay so far with this description here? More or less. Okay. So for those of you who want to learn more about the UML state diagrams, you can look it up. It's a little bit complicated because the state diagram is actually not just this simple. Okay, they have all kinds of transitions, all kinds of states, and there are all kinds of special states and all kinds of special transitions and whatnot. But the general idea is this. Okay, it captures how you can transition from one quote-unquote state to another state. One thing I do want to point out is this is not a flowchart. Okay, it is not a flowchart. In other words, it doesn't state the flow of logic. It states how things are changing. Is that okay so far? Because each bubble is representing a state of the entire app. It is not just saying, oh, we are doing this step and then we're doing this step. We are in this particular state. So it's not the same thing as a flowchart. Yep.
So this is a state, UML state diagram?
This is a state diagram.
Okay. Yes, UML also has where you have the object name and the class. Right?
That's a class diagram. That's a
UML.
class hierarchy. It is also a part of the UML. The class diagram is not applicable in this class, no pun intended. Because in this class, in cisp362, we are not dealing with Java, we're dealing with App Inventor. And in the App Inventor, you cannot make your own class, you cannot inherit from another class. So the class diagram is not really applicable in App Inventor type of programs, because we're using components. And the only thing you can do with components is to say, okay, I need more instances of a particular component, but you can't even stamp out new components on the fly when you're running the program. So that's why a class diagram is not really particularly helpful here in this context.
This diagram come before the class diagram?
This describes the behavior of something. A class diagram describes how a particular class of objects relate to another class of objects. So they're kind of orthogonal. They are not really, they're not intertwined so much. They're actually orthogonal. One thing does relate these two is for each object of a class, it can have its own state diagram. So an object has multiple states. So you can state, okay, what are the states of a particular object? Let's say you're dealing with billing, okay? So you can say, okay, a particular bill, a particular invoice is an object. Well, what are the states of this object? Creation, unpaid, sent but unpaid for, sent and then paid for, canceled, and so on and so forth. So each object, in this case an invoice, has its own internal states. But then you can also have a hierarchy of invoices. So you can have specialization of invoices, like certain invoices is automatically recurring, okay? Other types of invoices are one shot. And certain invoices are, have automatic actions, like if it's not paid by a certain date, some action will occur automatically. So you can now have subclasses of invoices. And then with each subclass, you might have a slightly different state diagram, because some state may not exist with some, and then it does exist with the other. So that's how these two are different. One is stating how to specialize something, and then the other one is saying, okay, if I make an object of this class, what are the states and how do we change from one state to another state? Okay, so now that we have this diagram, we can now go ahead and actually write the app. It's called Get 'em All. Alright, so we'll start with the components of the user interface. Only 3 things are needed. I'll put a label here, and then we'll go to canvas. Put the canvas here. We'll make it as wide as the parent, and in terms of height, we'll fix the height by pixels. Now you guys can do whatever you want when you design it. I'm just going to do it this way. And we have a multi-purpose button. Okay, we also have a ball sprite, and we'll just put it here. And then we have a single button. That's our multi-purpose button. So we'll just rename this as our multi-purpose button. And make it start with a particular name. What name should I start it with? What is the first use of the button? Start the game. Yep. So we say start, like that. All right. And
my specification says lowercase start.
Okay, fine. Lowercase start. Yeah. There we go. All right. So here we have the app. We have all the components included. Or did we? We're missing one component. What is it?
Timer.
Time. Well, we need a timer, which is a part of the clock. Okay, which is under sensors. So we got sensors and drag a clock into here. There we go. So now we have all the components needed, and we probably want to change this label too, because the initial label should be, I cannot remember.
Let's start the game.
It's my own homework assignment, and I cannot remember. But that's okay, because that's why I put it in writing. Go. There we go. All right. So now we go to the blocks, and the first thing we do is we look at screen 1 and say, let's do something. Let's see if there's anything we need to do for initialization when we first get into the game, or first get into the app. Okay, what should we do to initialize? There are several things. Okay, we have to center the ball sprite for one thing. And then 2, we have to come up with the 7 balls, random balls, paint those on the screen so that the game is ready to start, and we're just waiting for the end user to click the start button. Now let me read the description again and see whether whether the ordering is important or not, because it depends on how. Okay, upon initialization, which is the initialization event, the app should remain static. The text on the MP button should say start. The label should display that. Okay, so that means we don't need to do all that stuff from initialization. So the initialization is just this. Upon clicking of the MP button, if no game is in progress, then we will start a new game, and that is done when we click the button. Okay, so in terms of initialization, there's not much else we need to do. This is all we need to do, which is nothing. Okay, but the multi-purpose button is going to have a pretty complicated code here, because when you click on this button, it all depends on what is my current state, right? Depending on what the current state is, it will do something that's different when you click it. So now the question is, how do you track the current state? Yep.
If statements.
Huh?
If statements.
Using if statement, very good. But if when you use an if statement, you need to rely on some kind of condition that is either true or false, right? So let's drag an if statement in here. But what are you going to put here? How do you know that we are not in game right now and we need to start a new game?
We need a variable.
We need a variable.
Like a flag, kind of, but
Okay, so 1 means we are not in the game right now. 2 means we're in the game. 3 means we're paused. 4 means we're finished, and so on and so forth. Okay, that's one way to do it. But we already have something that can indicate that to us. And what would that be?
The button text.
The text on the button. Yep. So that's a tricky one. Okay, because we can actually use that to our advantage.
I use
Okay?
2 booleans.
Or you can use a bunch of booleans as well. Okay, so there are many ways to do it. But since the button text is kind of very specific and it is sensitive to what state we're currently in, we can just use that. Okay, but instead of using just regular text to compare, I hate making mistakes and mistype something and then the whole program doesn't work. So I'm going to use global variables for all of those names. So I'm going to have one string for just start itself, like that. I will have, basically I will make one global variable for every single label text for the button. So we have pulse, we have resume. So I just make a whole bunch of global variables. Okay, resume, and I just need to go back to my app here to find out what else do we have. So we got resume. During the gameplay, this is the long one. I don't like these 2 tabs being too far away, so let's put them closer together. Can't do that. There we go. And I think that's it. Okay, those are the 4. Yeah, there are only 4 states that we have. Let me switch back to the document camera. Because we only have 4 states, having 4 labels for the buttons seems to make sense. Okay. All right. So now that we have these, we can now say have a multi-branch conditional statement. So technically speaking, that should be enough. But for error checking, it might be helpful to have an else at the very end. So I'll show you guys why I have an else at the very end. All right, so each branch is going to be based on the comparison to one of these 4 variables. So we'll just have a whole bunch of comparisons. So go to text and go to compare, and we just have a whole bunch of comparisons. What are we comparing? We're comparing something to these global variables. So what is the other side of the comparison?
Text on the bottom.
The text on the button, right? Okay, so very good. So we go to the button, and we say, what is the text on the button? So we say button text, and then we'll just replicate this a few times, like that. Stick it here, 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 and here. And then we just drag our global variables and say, okay, this is, okay, we have to move things a little bit. Pause, resume, and new game. There we go. All right. So we'll do one thing at a time. We do want to make this, when we write this program, we want to make it that's easy to debug. So we'll only handle one thing at a time. The first thing we'll do is to handle what if the button has a text of start, which is the beginning of a game. I could just put all the logic here, but I don't want to, because if I put all the logic here, that means later on if I need to restart the game with a slight variance, I will have to do something else. So I'm going to make a procedure to do it. Okay. And I can do a certain way, I can make use of the screen in a certain way by making my own procedures to the right-hand side and all the event handlers to the left-hand side. So that's one way to organize the program. Okay. And this one is just going to be start new game. Okay. Now there are two ways to start a new game. One way is to reuse the 7 positions, and the other one is to not to reuse the 7 positions, right? So I don't want to. I can break it up into 2 different procedures, or I can use a flag to say, okay, do we want different positions this time, or do we want to reuse positions from last time? That's entirely up to you. But regardless of which way we want to do it, we still need a global variable for the circles, for the centers of the circles. So we'll have circles here, initialized to an empty list. So initially, there's nothing in this list. All right. Well, we'll just go ahead and instead of doing a start new game, which is a procedure, we'll have another procedure to come up with the 7 positions. Okay. So in this one, we want to say initialize circles, where we will go ahead and figure out the locations of the 7 circles and also store those 7 circles into the list. Okay. Are there any questions at this point? Okay. All right. So what do we do inside initialize circles? How do we make sure that we can end up with 7 circles and they're all at different places? What kind of overall control structure should I use in this case? Sorry?
A loop.
A loop? Okay. Well, we can use a loop. There are many different types of loops here. For each number, blah, 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 is a loop. Okay. For each item in the list, it's a loop. While is a loop. And I think that might be one more down the list. Nope, that's it. Okay, so these are the loops that we can do. Oh no, that's not. Okay, so for each is a loop. For each number is a loop. For each item is a loop. While test is a loop. So now the question is, well, which one should I use? There are 2 that kind of stands out and go like, well, we could go either way. What do you think? If you
I would use the 4 loop.
the 4 number, yeah, for each number.
Yeah.
Because we already know the actual number of circles that we need to paint is exactly 7, so we can use that. Okay. On the other hand, if you want to track the numbers and do the initialization, to compare and stuff like that yourself, you can also use a while test loop, okay, by maintaining and also incrementing the variables by yourself. Okay, so either way is fine. Again, there's no particular way of saying, oh, okay, this one is definitely a lot better. They're kind of equivalent. Okay, so we'll pick out the first one and just say, okay, for each number from 1 to 7, and we want to increase by 1. So right here, I'm going to stop and say, should I hard code everything here? The 1 kind of makes sense because the from one kind of makes sense because it's just a way of counting, and it's just determining, are we counting from 0 or are we counting from 1? I just need to go through 7 times, so it doesn't really matter where I start. But the 7, hard coding as 7 means that if you want the game more challenging later on, and say that, okay, after you complete each level, we'll increase the number by 1, okay, to make the next level up. Then you have to go back here and go like, oh man, there's a lot of stuff that we have to do to change. So let's parameterize the 7, which means turning the 7 from a constant into a parameter. So this way, whoever is calling this procedure gets to decide how many balls do we need. That makes the procedure more flexible. Okay. Is that okay? Does everybody understand what I'm doing here? Okay. Now, once again, if you're not using a procedure to do this and you're not parameterizing the procedure, no points will be taken off. Okay. It's just that when I do things, I kind of think about it like this. So I'm just more or less, talking to myself here, which I do a lot. Okay. So we say number of balls. Okay. And that's what we need to determine, okay, how many times should we go through this loop. Okay, very good. So for each iteration of this loop, we're painting a new ball on the screen. Okay. All right. So that doesn't seem too hard, or is it? This is actually harder than it seems because we have to make sure that no two balls are overlapping. So basically, before you can say, yes, let's go ahead and paint this ball over here, you have to make sure that it's not overlapping with anybody else. Okay. Well, how do we do that? Well, there's a logic to do it, but since I'm lazy, I'm going to say, somebody else will figure it out. Which basically is doing a procedure, and this time it is returning a result, and I'm going to say this procedure will find out, okay, not colliding, okay, not colliding. That spells right, I think, with other circles. Okay, that's not. These are not balls because I would call these circles because otherwise there would be some confusion between the ball sprite and the circles. So I'll call these circles. Okay. So the only thing I have to do here is to say in control, I say I need a loop in here because I need to keep coming up with random positions until I find one that is not colliding with any of the other balls, right? So I need another loop here. And this time, what kind of loop should I use? In other words, I'm asking the question, do I know the number of times I have to go through the loop to find a circle that is not overlapping with somebody else? Or do I have a list to go through to make sure it's not overlapping with somebody else?
Use a while loop.
Use a while loop because it can so happen that all the random numbers are very bunched up. So I keep poking about the same place all the time. So I really don't know how many times I have to go through this particular loop. So we're going to say here, we'll have a test, while test. Yep.
Is there a way to kind of just like mathematically kind of squish it or unsquish it to make sure that no circles will overlap? Like, I guess you can always just like have a grid and say, okay, we're gonna pick from points in this grid that you can just pick from there. But like, I'm just kind of wondering, is there a way to do non-overlapping without having to?
Yes. The answer is yes, but you may not like that answer. Okay, so mathematically speaking, okay, this is theoretical, mathematical. Okay, you look at all the possible coordinates as a set.
Yeah.
Okay, so if you guys don't know what I'm talking about because you have not taken CISP 440, just kind of ignore what we are going to talk about in the next 5 minutes or so. Okay, so you look at the entire screen as one single set of coordinates.
Sure.
Okay, every time you draw a circle, you take all the elements out, not only of the circle itself, but also everything that is a radius away from it. So this is the actual circle, but this is like one radius away from the perimeter of the circle. You remove all of these points from the set. So when you pick the center of the next circle, it can be any point that is remaining in the set. So you pick a point in the entire set, you use it, you remove a whole bunch of points around it from the set. Then when you need to draw another circle, you just pick any element out of the set because all elements of the set is guaranteed not to overlap with any circles.
Okay. And this will be uniform?
Sorry?
And this will be uniform. This will be the same thing as just picking 7 points that can't overlap. Okay.
Yep.
Cool.
Yep.
And so you represent the sets in a two-dimensional array of some sort?
When you represent a set of coordinates, that means 1 0, 1 1, 1 0, excuse me, 1 1, 1 2, 1 3, 1 4, and so on, all the way up to the entire width of the thing. And then the next row, so with a 300 by 300 grid, you end up with 90,000 elements in the set. And the time to subtract the points from the set is going to be pretty significant as well, because you have to compute all of these points in order to get them out of the set.
Then how do you pick from the set randomly?
Oh, it will just be random because you just say, okay, let's see how many elements do we have left in the set. Let's say we have 72,000 left. Okay, So you just say pick a random numbers, from
Like, so
1
you're
to 7
removing from a
2000.
list, and so then
Yeah.
your list length becomes the random number.
Becomes the range. It defines the range of the random number.
Okay.
Yep. And you pick any one of those, it's going to be a point that won't overlap with anything else. Yep. So theoretically, yes, we have something. We can do something like that, but the overhead of doing something like that is so significant that you might as well just kind of poke randomly and see if you are lucky.
Yeah, it makes more sense if you're going to fill most of the page.
Right.
Because then at the end you're picking a bunch that you have to. But if you're only picking a few, then it doesn't make sense.
Right. If it's sparse, then it makes sense to just randomly poke. But if it's dense, then it makes sense to do the subtractive method. Right. Or if you have a really quick method to do the subtraction, that works too.
Okay.
Yep. Okay, so we have a test here. As long as the test is true, we remain in the loop. So in this case, we're basically saying as long as the point that we have selected is overlapping with at least one of the painted circles, we want to stay in the loop. Okay. So this is where it is not very handy because App Inventor does not have a do while loop. In other words, there's no way to do something and then test. That would be sorry.
Why?
Yeah, it's really annoying because now you have to either initialize first or have some other variable to say this is the first time, don't mind it. Okay, but it's not too big of a deal. It is just a little bit annoying. Okay. But in order to do this, we also need local variables. So we'll stick a local variable block here, kind of move everything in. Well, I guess I don't need to move everything in. We can put this. All right. Okay, that will do it. Yeah, we can put it here, and then put this whole block back in here. There we go. So we'll need 2 local variables, at least 2. So we'll have an x and a y. So we'll call. This is already x. We'll call it y. Doesn't matter. The order is not that important. And then we'll put the test inside here because we need to refer to x and y. And because we're initializing here, we can basically save the initialization right before the test. So we can say pick a random number. So go to math, say random number, and duplicate this block. But then you have to be careful about which random number that you're picking because you need to make sure you're trying to specify the center of the circle. So basically you have to make sure that radius away from the left edge and radius away from the right edge cannot be the x, and then radius away from the top, radius away from the bottom cannot be the y. So you have to control the range a little bit here. And now we can say, well, what is the radius? Well, I'm going to pick 20 for the whole program. Okay, so I will have all the constants 20 all over the place, but that may not be a good thing, right? So we can make it a parameter. So we can now say, okay, pass another parameter here, which is the radius of these circles. So now I can just refer to r as a radius. So here we refer to r, get rid of this, get rid of that, and then we just specify r as the minimum because you have to clear the edges. The end range is not going to be 100 and 100 because in one case it's going to be the height minus the radius. In the other case it's going to be the width of the canvas minus radius. So those two will be computed as well. Now I can parameterize again in this case. In other words, I can use one parameter to say, okay, who is the canvas responsible for this program? I can do that to make this subroutine applicable to any canvas. But that's going to be like one step too much for this program. So there comes a certain point where yes, you can parameterize it further, but the return of parameterizing any further is not going to be that much. But it does induce a lot more work to be done. So I'm not going to parameterize the canvas here, but you can if you want to. So we just look at the canvas and we pick out, well, the height first because y goes first. So we look at the height, H-E-I-G-H-T, got the height, but we need the subtraction, so we go to math, we specify a subtraction. So we are using the height minus the radius, which is r, like that. And then we just kind of duplicate this block, except this time we are looking at the width, like so, in order to set the initial y and x variable. So what we are really testing is to see whether these two, this particular coordinate, is colliding with a particular painted circle already. So this one has to be parameterized as well, so that I can say, okay, where is the center of the circle that I am about to paint? Okay. And I'm not defining the body just yet, okay? And I'm already using it. So while test, oh, okay, maybe this one should be colliding. Otherwise, I have to negate it first. So this is a little bit more direct. So if it's colliding, we want to do it again and again. So now we call the procedure, which is colliding with other circles. Pass on our x and y that we have just computed. What does it mean when we get to the do part? Just reading the code here. Just reading it in English. While test, call colliding with other circles, x, y, what should we do?
Pick another place.
Pick another place, exactly. So we just need two other set blocks here. So we set x to be a duplicate of this, and then we replicate this block and say set y to about the same thing, except we are dealing with the height of the canvas. Okay, so is that okay so far? And by the way, this is your one application of top-down design. Top-down design means that you're trying not to focus on too much on the details. You're just focusing on the overall structure of the code, and that's exactly what I did. Because I just said, we'll just assume that something else is going to figure out whether the xy is colliding with an already painted circle, and if the answer is yes, then we'll go ahead and try another location. But I haven't really specified the body of this function. It's just there with nothing in it. But that's fine. That is your top-down design, so that I can focus on this level of code first before I move on to that level. Okay. So assuming that I have that procedure, this block of code should do what it's supposed to. Okay, this block of code will eventually exit, and I end up with an x and a y, where those are the centers of a circle. It is not colliding with anything else. So now I can actually go ahead and draw that circle. And when I draw the circle, I need the radius, I need the xy, and I also need the color. I don't want to fix the color here. I want to specify the color as another parameter. So I drag another parameter here, and just say, okay, this specifies the color of the circle that I'm drawing. So that when I'm getting out of this local block here, when I'm getting out of this while test, I can now say, okay, let's paint the ball, because I know that one is not colliding with anything else. So we go to canvas, which is the only thing that can draw a circle. We say draw a circle, and we have to put it right here after the loop, but inside the local variable block. The center of x is just local variable x here. Center y is variable y. Now, when your code gets too big and the blocks are just kind of scrolling all over the place, you can shrink certain portions so it's no longer interfering. So in this case, I can just collapse this particular block, so this way I can easily focus on the other stuff. So the radius is here, and we want it to fill. Oh, wait, how do we specify the color of the circle? It's not a parameter to the draw circle thing. What do we do? Do you guys remember? It's a property of the canvas itself. Okay, so we have to set that property first. We go back to canvas, and then we say set, I think it's called paint color. Yep. to the color that is a part of the parameter. There we go. All right, so that should kind of work. Okay. Well, I'm so anxious to test whether this block of code is working or not. So what I'm going to do is to say, let's worry about this later. And just say that, nope, it's not colliding. Well, at least I can see whether it's painting 7 circles or not. Is that making any sense? Yep.
They still use the term stub.
Yep.
Yeah.
Yep. It's basically a stub. But this is applied in the case of quote-unquote agile development. Okay, in the sense that you're not just making a stub so that it looks like it's there. It actually works. The program does work, but we know that it's lacking the feature of making sure that things are not overlapping. But other than that, it should paint 7 circles if I pass 7 to it. Okay. So now I just need to make a call to this thing. Okay, start a new game. It's just going to initialize all of these things. And without using any further parameters with start new game, I'm just going to specify all the constants here. So the first one is R. R is going to be, let's say 10. Okay, we specify a radius of 10. And number of circles, let's specify exactly 7, which is what we need. And then for color, we'll just go to colors and pick a particular color that is not the background. Okay, we'll pick green. There we go. And now we can test the program. In this particular case, because we are not having a multi-screen application, and also we don't need specific path to resources inside the app, we can just go ahead and use the built-in emulator using AI Companion. So let me go start that. There we go. Come back here. Oh wait, nobody's calling start new game. So I need to make sure that we call that when the button is start. Okay, so we need to make that procedure call to start new game right there. And now we can start a new emulator and see if it works up to this point. Did anyone encounter any major challenges with this particular app? Or okay, and what would that be?
When I would move over the circles real fast, sometimes it would decrement my count. Actually. Oh, also when I erased the circles, it left a halo.
Okay.
So I had to end up erasing a little bit.
Okay. Well, the halo has to do with smoothing, the smoothing function of painting a circle. Okay, so let me explain what that means. When you draw a circle, if anyone wants to use this idea and actually build a house, along Highway 1, okay, go ahead. I'm not going to collect any royalty fees.
We have to bike over.
Just don't come back to me if something does happen to the house. Okay, so when you draw a circle, okay, so I'm just going to look at individual pixels here. So this is like super magnified, okay? But when you draw a circle, okay, the edge of a circle is never really just the whole pixel, right? It's usually like covering half a circle along the edges of a circle, right? So the circle, in this case, can be like this, okay? But when the circle is displayed, now this pixel is easy, okay? Just paint the whole thing. Easy peasy. What about these 3 pixels? Well, if you say if it's more than half, paint the whole thing. If it's less than half, do not paint. If it's less than half, do not paint. Your circle will look very jagged. Okay, it will be very pixelated. Even without magnification, you can see the edges is like that, like a saw blade. Okay, so what most programs will do, or most GUI, would automatically smooth edges, which means it would actually look at the ratio of, okay, how much of it is supposed to be a part of the circle? Okay, let's just call this 80%, okay? Then it will basically paint this entire pixel using 80% of what the circle is supposed to be, and then the other 20% is what was here in the beginning. And then over here, oh, let's look at this one. This looks like 5%, okay? So it will only use 5% of the color of the circle, and then 95% of the original color of the pixel. And we'll look at this one and say, well, that looks like maybe 15%. So it'll be 15% of the color of the circle, the fill color, and then 85% of the original pixel.
So it actually means a different color as a
Yeah,
combination
it is
of
different.
the two colors.
Yeah, it's a blend of the two. But the blend depends on the ratio of how much of the circle is supposed to be covering that particular pixel. And that's smoothing. And most GUIs now do smoothing without an option to turn it off. Okay? So, well, the app is up and running. Let's paint, 7 circles. 1, 2, 3, 4, 5, 6, 7. And they're not overlapping just because they're not overlapping, right? And obviously, they're now definitely overlapping, right?
Oh, that's a cool feature.
Well, this is a crippled app, right? If you don't pay me, in-game purchase, this is all you get. But that's how you. But this is the way I write my app, is to write it in steps so that it's easier to test. Okay. We're going to run out of time, fairly soon. So before we run out of time, I will continue this over at the lab. Okay, so I will continue the development of this app here. But I want to show you the new homework assignment, which is not too bad. It is based on this one. So get them all as quickly as possible. So the description of this homework assignment is an enhancement to the previous assignment. In this assignment, I want you to add one more label to the screen so that not only at the end of the game, but it always displays the total distance traveled. And the total distance traveled is not the drag distance. It really is just measuring the distance of all the points where you have illuminated circles. So the first circle does not trigger this. It would actually zero the count. But the moment you erase the second circle, the distance from the first circle to the second circle will be a part of this sum. And then you go to the third one, then the distance from the first to the second, and the second to the third will be the distance, total distance in pixels.
To the center.
Center to center,
From
correct.
center to center.
Yeah, center to center. So it is a minor modification to your program at this point, because you need that logic to detect, okay, my sprite is over which circle. You have that detection mechanism already, right? And you also have a mechanism to track which circle is, well, I guess some people may or may not have the mechanism to track what was the last circle erased, and that's all you need to track the total distance. You just need to know which one was the last circle, or what is the center of the last circle that I have just erased. And then you can use that to kind of keep adding on top of this. And then by the end of the game, you would just display, that summation would just be the total distance that you have quote unquote traveled. But we're not looking at the drag distance, which is going to be like much longer. We're just looking at the sequence of getting the circles erased.
And that number's in pixels?
In number of pixels. Yep. So that makes it very easy. You just look at the XY, and then you do the yep. And just keep adding to that sum. Yep. You don't really need a sum because you can use the label, the text of the label as a number to process, to add to it. So it works too. It's not a very good approach, but that works too. So it's a minor modification to your program, and if you don't have a working program in this case, then you have to wait until I get my program working, which is probably sometime in the lab.
And then you add the DB and put the result there, and then you.
Exactly, but that's in the next project. So I'm going to give you like little steps. Huh?
Are we going to keep going?
Yes, we can. I think we can make this one actually a viable game. That people would actually pay money to play.
This is an exercise in feature creep.
Yep.
Or agile?
Enhancement. Well, when this app starts to have wheels and electric motors
And you can order pizza through it.
yeah, then we start to have feature creep. Well, actually, in the case of a Tesla, you don't need to order pizza because you can drive to a pizza parlor.
Can you get the Tesla to drive to the pizza parlor for you though?
Yeah.
I think
Yeah,
Alexa
that's-
will order your pizza for you.
Already.
Sorry,
Alexa will order your pizza for you from Domino's.
but that kind of
My TV can order.
But the thing about having a car is you can go there, right?
Yeah,
Why would you
it's-
want to go there if you don't have to?
If it's self-driving,
But you don't need a car to begin with.
I want to delegate. I want somebody else to get it for me.
If it's self-driving, it'll go there for you.
Yeah.
Just tell the pizza place to put it in the car.
I want a Tesla or a Lexus that can, that is like I'm not sure whether you guys watch Japanese anime or not, that has a trunk, and when you open the trunk, you can drones will fly out of it
Oh.
to get stuff for you.
They have a delivery van that's being developed that has 2 drones on top, and it has a whole system that loads it. This drone
Yep,
will fly
but
out.
this will be like my personal
Your
vehicle,
personal.
and I can just drive by, like Papa Murphy's, and place the order ahead of time. So I need to drive by without leaving the car or even parking. Okay, so when I'm within half a mile away, the drone will take off, go ahead, of myself because I might be stuck in traffic, pick up the pizza, come back, so that I don't have to stop at all.
Right. So they just have to put it outside, or what?
You'll put it in the trunk, I guess.
How's your drone gonna get in the store?
Hmm?
How's your drone get in the store? You're gonna have to leave the pizza on the sidewalk, right?
They will probably leave it on the helipad.
Oh.
So when the drone approaches, it will self-identify,
Oh, okay.
whose drone it is, and then Papa Murphy will have a robotic system to say, okay, this is the order for tack. Put
Or
it
if your
up.
Tesla just has a retractable hood, have it drive it to the pizza place, retract the hood, have them throw in the pizza, and then close the hood, and then come home.
Now I need a refrigerated trunk to keep my Papa Murphy pizza refrigerated until I get
You
home.
want it to be warm though.
Heated.
Or cook it during the time I'm driving, so by the time I get home, it's done.
You have to have power in it. That's
Well, I mean, in summer.
For maybe a few pizzas, right? Then it would drive to the next, closest recharge station to recharge itself, while you're enjoying the pizza in the car. Now that would be feature creep. When it started off with this and it ends up with that, yes, that would be a feature creep. All right, so we're gonna vacate the classroom. I'll go to the lab, finish the project, and you guys have the next project also assigned. So if you want to work on your own project during the lab time, that's cool. If you just want to watch me working on the app, that's cool too.